stream it to YouTube. Okay, I think we're here.
Okay. Thank you for the invitation for this Git tutorial. So the plan is to cover a review of the Git material of the software carpentry lesson, and then present Git bisect that's a tool that you can use to locate a bug that was introduced in your code, and later present Git rebase. That is a nice way to keep your Git tree a little clean. So if you go to the Etherpad on line 6, there is a link with a few instructions to the repository that we are going to use for the demos of this tutorial. So if you already download, if you already copy the Git repository to your GitHub account, please put a +1 on the Git channel so that I can go ahead and move to the next session. If anyone needs a little time to cover that part of the lessons, just let me know and I go to follow that just very quickly. So the idea is to go to the GitHub importer and copy a Git repository that I create for this lesson. So as I said, the instructions are on the lessons. So I just fill with a name for the repository and I go to import that. Wait a few minutes to import the repository to a new location. And I can click to continue to the repository. So this is the repository that I'm going to use for the demos. So we can copy this address. And can get on and wait a few minutes to get the data on our machine. And after that, you can change the current directory to the repository that you just cloned. And we have just one file on that Git repository. Okay, everyone is on that already cloned the repository. Jessica? Okay, so when you start using Git a lot, you are probably going to have to type a very long comments. So for example, if you want to see the Git history of your repository, you can use this command git log all ref decorate and one line. So you have one line for each comment and Git represent as a graph and put some annotations. So we have this output. So it's a very good command that I use a lot for see what's the states of my repository, but it's a very long command. So if you start to type that very often you get boring. So Git has something called alias. That's like a shortcut that you can create for your own comments.
Hey, Ron, you're right. Can you hold up for a minute? We are having some technical issues. Yeah, sorry.
Okay.
I will let you know when we get this better.
Okay, just leave it. Okay, Ranieri, can you say something?
Yes, when it's okay, the audio.
Is this better? Okay.
Okay.
Where I should start again?
How are you guys doing? Do you have this cloned, or do you want to start all over again? Okay, they have it cloned, so let's go ahead and start from there.
Okay, so backing a few steps after you clone, you cd to the new repository, change the current directory to the new repository. So cd 2016 1 2005 git sample. This is the repository that I cloned. And on that, we just have a file. So as I said before, if you use Git very often, you're probably going to type very long commands like git log all graph decorate and one line. So this will give you one line for each comment that you have on your repository in a nice way with some decorations. So this is the output. And the bad part is typing this long command will take some time. So to solve this issue, Git has something called alias that is a way that you can create your own commands that will be transcribed to Git commands. So you can create a new command that will mean the command that you just type. So for that, we can use git config. So if you remember, you use config to add your name and user and email to Git, so he knows who you are. And you are going to use global so that the option will work for all the projects. And after that, alias, followed by the name of the command that we want. So I like to use LGI. And after that, the command that you use, so log all decorate graph and one line. So after you type this command, Git will add the LGI on the Git configurations. So if you type again Git LGA, you're going to get the same output as before. It was clear for everyone? Jessica, how people is going? Any questions so far?
No, we're all good so far. Thanks.
Okay. So when you create your own command, it will use the command that you create, but you can also add options to that command. So we can limit the number of comments that Git will show to us. So we can use Git LGA and put a number after that. So just get 3 comments instead of all. So just 3 comments. And you can use all the Git log options on that. So it's a very nice way to type a little less than all the old long commands. And it's a very good way to remember the commands that you use very often that has too many options. So let's go for exercise. I will put on the Etherpad what is the descriptions of the exercise. So on line 11, challenge number 1. So create, as describing the following, the alias and the command. So use A for add CAN for commit all messages. I for init. P for push. Jessica, can you let me know when people did the exercise?
Yep. Yes. Can you switch your screen to display the Etherpad, or is that difficult?
You know, I can do that.
Okay, that would be great.
Give me a second.
I know there's a lot of tabs.
Yeah. I have no idea how many tabs I have.
Mm.
A lot.
Okay. Yep, that's great. I will let you know when we're done with that.
Okay, thank you.
Raniere, we had a question. Oh, well, Titus is typing them, but is there a way to undo aliases?
Okay, so
Yeah.
you can undo the alias just, if you want to replace it with something, you can just repeat the command. So it will replace that. And if you want to remove one of those, just know, go into the Git configuration file and drop that line.
Okay. And then the second, yeah.
And the difference between a local and a global alias is that you can have alias just for one project. So if for like one project you need to have some default files that conflict with your global, for example, on the Git soft caption lessons, you have to add the HTML files to the history. So normally I have HTML files on my blacklist. So for example, I can use add as an alias for add for and force, so I can force to add the HTML files. That's make clear the difference?
I think so, yeah. And I think we are still, another question?
Yeah, is there a way to list all aliases?
Is there a way to list all of aliases?
I don't know, really. You can open the file and look at the configuration file. Most of the time I do that, but I don't know if there is a way to list all the alias. Depending of your shell, it will autocomplete the alias. So it's something nice. But I don't think that works with Bash.
Config minus L, not so much information.
Okay, so git config minus L will give us some information, it looks like. Yeah, okay. And are we still working, or?
Yeah, there's another command right there that will list the aliases specifically.
Okay, yeah, we're still working, so I will let you know when we have more questions.
Yeah.
Okay, I think we are all ready to go. If you want to go over how to do this,
Okay.
fun, yeah.
Yeah. So let me show the solution for that exercise. So we just repeat the same command that we see before, but changing the alias. So get config global alias a add config global alias and commit on global alias I init git config global alias t push. Okay, so this is the solution for the exercise. And I have another challenge for people, because normally when you have a lot of configurations on your git config file, you want to share that with many machines. And a nice way to use that is using Git and GitHub. So the second challenge is to create a repository on GitHub and send your Git configuration file to that repository. So challenge number 2 on the Etherpad. So try to use the alias that you create on the previous challenge, so just you can know how this works. So first create a directory called .files. You can wait. So you can create the directory anywhere in your file systems, but be okay if you create that swc git intermediate.file. And you need to initiate the repository. It would be nice to have a readme.file and create a commit for the readme, then copy your git configuration. And for last, a commit, and I forgot to this one to and distribute that.
Okay, thanks. We'll get working on that.
Okay.
Okay, I think we're good to go. If you can talk through the steps.
Yes, okay, let's go through the steps for this. So let's create a directory. So you see, git files and change to the directory that we just create and use git init. That's great. I go to create a file with echo, just readme.md, and I have that file get add, and the file get commit all message and add the readme file. So we can get LGI and see the commit that we just create. So I already covered the steps 1, 2, 3, 4, 5. Now let's copy the git configuration to that directory. So it's our git configuration, git config. So git status and can get commit, add config. So now that you create the configuration file, we can go to GitHub, create a new repository. So I'm going to add the date just to not conflict with my other repository. And then I can just copy this line and paste that and get push orange. And not so good. So let's refresh this. And this is okay. We have our repository. Any questions, Jessica? Okay.
I think we're all set. Thank you. We're good.
Okay, so now I'm going to move to the second part of this lesson, and we're going to talk about git bisect. So bisect is one of the functions that Git have that you help you locate a commit that did something that break your code, like a bad, we normally call that a bad commit. So that's a few histories that I came across of how Git bisect is very useful. So once I was working on a project, and after I changed the version of the software that I was using, the time that I spent to get a solution changed from like a few minutes to almost a day. So I went to use Git dissection to try to locate the commits that make that change. So, and after that, I can understand what was happening on the source code that make this huge difference. So I'm going to use that repository that we just cloned and for experiment with git bisect. So let's go back to the repository and let's check that we have this en.dc file. So this is a dictionary file. You can have a look on that on the first lines. So each line has a bunch of, each line has one word, and the size of that file, it's Jessica, what's the problem?
There's no problem. We're okay.
Okay, sorry.
Yeah.
So the size of the file is huge. So it has 43,000 lines. And if you're going to look at the Git history, you're going to see that at some point, the word Python was introduced to that file. But if you grab that file for Python, I'm going to have the lowercase Python, and we want the uppercase version of Python. So if you use the git log, you can locate the commits that introduce the word Python to that file. So anyone can put on the Etherpad the commit of that introduce the word Python with uppercase first letter. So a very small challenge. Number 3. What commit introduced the word Python? You don't need to do any fancy stuff to get that information. Just look at the log of the Git tree, and you should get that information easily. Yes, so it's the CDE 9009. So you can get that information with Git. And so this is the commit CDE 9009. So if you check out this commit Git, check out CDE 9009. Okay, let's just give him a second, Titus. You can check out CDE 9009, and you can grab for the word Python on that file, and you're going to see that the word Python with the uppercase letter is on that. I'm going to use blame later, okay, Titus? After I cover bisect, I think it'll be better. So let's go back to master git, check out master, and let's start using bisect. So to start bisect, you use git bisect start, and that will add some information to Git so that it will use for the bisect. And we need to inform a good and a bad commit. So the bad commit is the master. So git bisect bad and master. And our good commit is the CDE 9009, git bisect good CDE 9009. And after we inform the bad and the good commit to Git, it will change our position on the history to the next commit that we need to inspect to check if it is a good or bad commit. So now we are on the EE 405 commit, and you can grab that file to check if that is the uppercase letter Python. So grab Python and oops, I need to pass the name of the file. Since there is no Python on that file, I'm going to mark that comment as bad. So git bisect bad. And I'm going to repeat these steps a few more. So now on 51BD45, I can again grab. So grab Python and the name of the file. Again, that's no Python on our dictionary. So we mark this expression as bad. So git bisect bad. And again, on EE8733, we can grab. And we check that there is a Python on that file. So we mark that commit as good. And after a few steps, Git will inform us which is the first bad commit. So it's the 51BD45 that dropped the file, the name Python with the uppercase letter. And we can locate that file using git log. So this is the file here that introduce, not this one, the 51BD. So this commit introduce the bug on our dictionary, and it's after a few steps of the comments that introduce the word Python and a lot of comments before our master commit. So now that we know on which commit the change was made, you can have the information about who was the author of that commit and all the other informations. So Git showed that a few steps earlier for us. So we have the commit, the author, and the date. And after you have this, you can do a few things to undo this. You can you can reset your commit, you can undo this, and a lot of other stuffs that I don't going to cover on this lesson. So after you bisect your project, you can use git bisect and reset to stop the bisect and go back to the commit that you start on the beginning of the bisect. Titus asked to mention git blame. So you can use git blame and pass the name of one file. So our dictionary, it will show you for each line what is the last comment that changed that line. So for example, the first line was changed on the commit EE8733. The second line was changed on line 87DB. The third line was changed on EE87. The sixth line was changed on 5121EE, and you can go all down with the changes. But git blame will only cover the line that is on the file that you're seeing at the moment. So it will not get the Python with the uppercase version of that, because that line don't exist on the file. Jessica, how is people going on? Questions?
Okay, I think we're doing okay. Yeah, I will let you know if we have questions. Just as a general point, can you at some point post the code that answers the challenge questions in the Etherpad or in the lesson materials, just for reference? It can be after that. Yeah.
Okay.
Okay, that's it. But I think we're good to keep going. Yep.
Okay, let's go back to this. Can everyone see the screen? Okay. So this is animation with the Git history that we have on our example. So let's wait a few more minutes, and now it starts, and we mark this and going all over. So the blue comment is the comment that we are inspecting, and when the blue goes to red or green, this means that we use git bisect bad or good to mark that commit as bad or as good. And the bold red commit is the one that first introduced the bug on our code. So it's a small animation with all the steps that we go through a few minutes ago. And for bisect is this. I try to find a good challenge for this part of the lesson, but I really fail on this task. So I think that people on Davis can go to a break, and before the break, let's just go cover brands. And I forgot that, so let me back to the terminal. So brands, it's not the best name for understand what this means on Git, but people use the name just because of lots of notations of Git that came from game theory, graphic theory, sorry, and other stuffs on that. So people use branch to means a different sequence of comments that you have on your tree. But I think that a good way to think of branch is if you think of that as a thumb tag that you can put on your Git tree. So you can add and remove thumb tags as you like. And you can have as many thumb tags as you want. There's no limitations of how many thumb tags you have. Something that is important to understand is that every time that you have a thumb tag on a leaf, on the last Git commit, and you change that, most of the time the thumb tag that you are will move of the commits. So it changed the commit when you increase your Git tree. So let's see which of the branch we have right now on our Git repository. So you can use Git branch and pass all options. So we have 3 branches on that repository. We have the master branch, the remote orange head, and the remote orange master. The remote branch is like a thumb tag for what is the positions of that thumb tag on GitHub. And right now we just have this master thumb tag, and we know that we are on that thumb tag because of this star at the beginning of the line. Oh, and we can create, we can locate the thumb tags on our Git tree if you use Git, and the first command log that we saw on this lesson. So all the 3 branches or thumb tag are on the same commit, this 3F3C1BF. And you can create, you see this head right here, that's another thumb tag that's not shown before when you ask for branch also, because this is a special one it's mark our current positions on the gate tree. So we can think of that as the pin on your GPS app that you use. So the head will change that positions when we change the commit that we are using. So before this lesson, I use git checkout. So git checkout to CDEE 9009. So after that, if I look on the head positions, going to see that was changed to the CDE 9009. And when I get checkout master, and inspect again, going to see that the head changed back to 3F3C1BF. So head is this very special temp tag that Git has. So let's go to a few nice options and interesting things that you can do with branches. We can create a branch using git branch and say passing a name of the branch that you want to create. So let's using abduction. And now if we list all the branches, get branch all, we're going to have now 4 instead of 3 branches. And as you can see, we're still on the git master branch. And if you inspect all this, our git tree, going to see that all the 4 branches are on the same positions, the temp tags. If you want to move to the abduction branch, you can use git checkout abduction, and you can again list all the branches and see that now we change the branch that we are. So let's do something. Let's add that abduction word to our dictionary. So echo abduction and append that to our file. So we can see that the file, the start of our Git repository. So the file change and you can get the diff. So our abduction is add to that file and can add that file and create a commit with that. So add abduction. And now let's inspect what happens with our get tree. So get LGA. And going to see that we create a new git commit, like name it E196B4C. So it's the abduction branch is on that commit, and all the other 3 branches are before this commit, so they still on 3F3C1BF. And we can send the branch to GitHub, so you can get push orange abduction. And after we send that Git branch to GitHub, can again look on our Git history and see that now we have an origin abduction branch. So as I said before, this orange branch, just it's a mark for the branch that we have on the remote repository. And if you list all the branches, you see that we have all 5. So abduction, mass, remote orange head, remote orange abduction, and remote orange master. So we can go back to the master branch if you want. And have the file, so we can tail that file and see that there's no abduction on that file as in Git, the abduction master. fail. So files are different on each branch. So branches are a very good way to keep two different timelines of your project. It's a nice way to get to use branches when you create pull requests that you're going to see in a few minutes. Now, before we move ahead, let's go to a challenge. I go to put that on the Etherpad. So challenge number 3. Number 4. So the idea is to create a few branches and play with that. So create a branch called genomic and another one called voluntary. That should start on 3F3C1BF. That's on your master branch is. And after you create that branch, create a commit adding the name of that branch to the dictionary file. And after that, just send these 2 new branches to GitHub. Questions about the challenge?
I don't think we have any questions. We'll get to work on it, and I'll let you know when we're done. Try and stay dry over there. Okay, I think we're ready for you to explain this.
Okay, so let's go. So it's to create a branch. So let's get, we first need to know where we are. So we get branch. So we are on the abduction. So let's move to master, get checkout, master. I can use master since it's the same positions of 3F3, C1, BF, and then get branch genomic, get checkout genomic, and echo genomic, and add that to our dictionary file. So get status, so we can get diff to check our progress, and then since it's okay, let's get commit. I'll put a message on that. So add genomic, and then you can repeat the same steps for voluntary, but let's do that in a different way. So let's get checkout master. You can use options for checkout if you want to create a branch and check out to that branch. Get checkout -b, and you can pass the name of the branch that you want. So voluntary, and if you stack get branch, I'm going to see that get create a new branch, and we are now on that voluntary branch. And if you want to double check that, so get I, and you're going to see that the voluntary is at the same positions of the master branch. So let's continue. Let's add that word to our dictionary file. And you can get commit our message very, and you can push both branches with the same command. So get push orange, genomic, and voluntary. Wait a few minutes to get push work, and you can go to GitHub and refresh that page. Not this one. This one. So we can see that Git already has the 3 branches that we create, and you can check here with branches that we have master, that's the default branch on GitHub, and we have genomics, voluntary, and abductions branch. So far we are good, and I hope you too. One last thing before people go to the coffee break. I go to explain the detached head state. So when you move like to a place that is no thumb tag, that's no branch on that commit, or even if there is a branch, but you give a checkout to the commit and not to that branch, Git will go to the detached head state. So let's try that. Git checkout, and that's the number 3F3 C1BF. So every time that you go to the detached head, you're going to get this message. It's a warning message from Git saying that you are in the detached head state. You can look around, make experiments changes, and commit them. And you can discard and commit to make in this state without impact and branch by performance another checkout. So if you don't put a branch on the comments that you create on the detached head, you like lost that comments on because you don't have a thumb tag to go back. And if you want to create a branch from a detached head, you can use git checkout -b that you just used before. So you can use can create another branch. Before create a branch, you can make some changes like add camp to the dictionary file. So echo camp and add to that file. So get status. And going to see here, git is on detached at 3F3C1BF. And there's informations to avoid that because you can lose your changes. But let's continue without take a look on this warning. So get commit -a-n add camp. So you see this, it's detached head and the new comment 74AD. If you want, you can go back to master, get master, and get checkout master, and going to get a warning saying that you are leaving one commit behind that is not connected with any thumb tag. So it's the 74ADCE. And if you want to keep that commit on a branch, you should probably use get branch, put the name of the branch and pass the commit number. So if you use get log, you're not going to but after that, you can get push.
Hey, Ranieri, I think your connection dropped out. So we're gonna go to a break and then we can finish this up in about 15 minutes. I'll put the time in the Gitter channel.
Sorry, my connection just dropped out because of the rain. Jessica?
Hi, we're gonna go to a coffee break.
Okay,
Figured it was a natural stopping point.
yes.
So probably a couple minutes, maybe in about 12 minutes, 15 minutes,
Yeah.
we'll be back. But I'll put the information in the Gitter channel and we can recap about this. Yeah.
Okay, thank
All
you,
right.
sorry.
That's totally okay. we're back from the coffee break and we are ready to get going again.
Can you hear me, Jessica?
Yep, I can hear you now. We're all good.
Okay, so before the coffee break, I was talking about the detached head. So let's see a few steps back. So you move to commit, and we enter in the detached head and make a few changes, create a commit. After the comment, we go back to master. We got a warning saying that you are leaving one commit behind that was not connected to any of our branches. And we follow the tip that Git provide to us so that we create a branch on that commit that was left behind. And explanation just drop out. And let's try again. Okay, so now we have, I think, 4 branches on our repository. Okay. So we have a camp branch, a genomic, a voluntary, and a abduction branch. If you have all these 4 branches, you are ready to continue the lessons. So now that you learn how to create branches, we're going to learn how to create pull requests. So when you go to the homepage of your Git repository, you normally get a green button for a quick way to create a pull request from any branch that you just upload to GitHub. So let's skip this green button here and let's do the normal way so that you can create for any branch. So using this new pull request button, and you're going to need to select the 2 branches that you want to go. So the base branch is the one that you want to merge with the master one. You can use any of the branches, but you're going to use the abduction one. So let's go select abduction. I always mix this. So you're going to use master as the base branch, and you're going to compare against abduction. So when you select master as base and abduction as compare, going to have this screen that has a title for your pull request. That is a text field that you can describe the change that you make on that pull request. And you can see the difference covering by that pull request. So just add this abduction line on that pull request. So you can, using this button to create a pull request. And pull request created. So you can go back again and create a second pull request. You can use now the quickly green button. So if you use that, you already go to select the branch that you're going to use. So I select the voluntary one now, and I can again create that pull request. normally going to create a pull request not against your own repository, but against a repository that you forked. But for this lesson, we are going to stay just with pull requests with our own repository. So a small challenge, just create the last two pull requests that we need to. So create a pull request for genomics and camp. So challenge 5. Create a pull request for all the brands. GitHub against the master branch. Jessica, could you let me know when everyone's complete the challenge 5?
Yep, I will do that. Okay, thanks. Ranieri, do you want us to merge the pull requests or just create them?
Not now, just create the pull request.
Okay. Okay.
5.
Okay, we are all good to go.
Okay, thank you. So if you have the 4 pull requests and you go to this tab on GitHub pull requests, you're going to see all the 4 pull requests that you started. And let's select the abduction one. And if you scroll to the bottom of the page, you're going to see this merge pull request. And let's just merge this abduction branch into master. So after we merge this, it's all okay, and you can fetch that on our local copy. So let's get fetch orange. So we are going to download the changes that has on GitHub. So you can see that it downloads a few changes that happens on the master branch. So if you take a look on the Git tree that you have, you're going to GitHub, the orange master, and you have the camp, the voluntary, and the genomic.
Your screen dropped out, so you dropped out for a second. Can you share your screen again? Sorry.
Oh, sorry.
Yeah, no problem.
Okay, so let's go. So I use git fetch orange to download all the changes that happens on GitHub. After that, I take a look on the Git tree that you have. So I take a look on the Git tree that we have locally. So we have the orange master, and on GitHub you have the abduction locally and on GitHub the camp, voluntary, and genomics the same. But the master, the local master branch, and is not on the same position of the orange master that is on the GitHub. So we're going to master and merge master with the orange master. So our local copy and the GitHub copy is at the same position. So git checkout master and git merge orange master. So you can check that now the orange master and the master is at the same position. So this is good. So this is what we want. We want that master is the same positions of the master on GitHub just to avoid problems. And now we can try to go and merge one of the authors' branches and pull requests, like, for example, can go try to merge genomics. So let's go back to GitHub page, select pull requests, and select the genomic one. If you scroll the page a little bit, you're going to see that there's this warning that this branch has a conflict, and you can merge that on GitHub just because of that conflict. If you attend a software carpentry workshop and your instructor talk about conflicts, you already know one of the forms to solve this problem. You can use merge locally, so we can use merge and solve the conflict. Today, I'm going to show how to solve this problem with Rebase. And after we solve that with Rebase, I go to explain the advantages of using Rebase instead of merge. So let's start. We need to change to genomics. So git checkout genomics. And we're going to rebase genomics into master. What this means is that we're going to cut the genome branch from 3F3C1BF and put that on top of the master branch. This means that you're going to keep the changes from genomics, but change the positions of the branch. So you can do that with git rebase, and use the name of the comment that you want to use as the new positions for the father of the genomic. So git rebase master, and going to see a warning message saying that was a conflict, just as we're going to have with if you're using merge. So now you need to open the dictionary file and solve the conflict. The file will be the same as when you use merge. So let's open that with nano. So, and since it's on the end of the file, let's go to that positions. You should scroll the file up very long. It will take too much lines to go to that. I probably should have chosen another text editor to do this instead of nano, just to scroll to the end of the file more easily. A few more seconds to get to the end of the file.
We have an audience tip that Control W, Control V will get you to the end of the file.
Control V, okay, thank you. So this is the end of the file. Thank you for the audience for that tip. So let's remove this line and keep the abduction and genomic. So now we can save the file and keep the same name. So get diff, you get the difference on the file, and you can get a status. So when you use rebase, you get the file and have a conflict. You need to solve that conflict and proceed like when you solve the conflict with merge. So get add and the name of the file that has a conflict. But now you just use get rebase and continue. So after you continue the rebase, since there's no conflict more, it will apply the changes on top of master. So you can check the changes using git lgi. So you can see that now the genomic branch is on top of the master branch. The master is the parent of the genomic one. And you can send to GitHub this change. So git push orange genomic and see what happens. You're going to receive a rejected message just because you change the positions of where this branch started, and to avoid you lost anything, GitHub will reject your push. So since you are 100% sure that you want to make these changes, change where the branch started, you're going to use git push -f orange master. Give me a second. Sorry. So let's back. I was saying that since you change the father of where your branch started, you are going to need to force that push. So git push orange master. This will ensure that git as not master, sorry, genomic. This will ensure that GitHub accept your push with the new comment, so we can go back to GitHub and refresh that page. So now GitHub accept, you make the push pull request. On that pull request, make the merge after you use Rebase. So we can go and merge that branch. So can again go back and fetch the changes. And again, you're going to need to merge master into orange master. So git checkout master and git merge orange master. And let's take a look on the git tree. So git LGA. So here we have this new master that's the same locally and on GitHub. That's cover has the genomics and the abduction. You can see here that the tree it's very simple, very clear, because we don't have brains from the very long time ago. Just to have demonstrations of what happens when you have, what is the difference you get from your git tree when you use Rebase and merge. Let's merge voluntary into master. So git merge voluntary. You get a conflict. So let's solve this conflict again. Going to use Vim this time, just because I'm very much faster with that. So this is the change. So let's remove that and keep the 3 line abductions. Going to see that you need to add the changes that you make. So git add. And to finish the merge, use git comment and can put a message on that. So, merge. Very long from the father and the merge comment, but we have this from the local one, this one that is start on
I think your audio is going in and out.
It starts with F3C1, and then you have D0F4, and then this B52F. So this green line here, as you see, it's a little difficult to keep track of the commits that come from the very past. And we use Rebase. You have a much small branch that is easy to track. So this is one of the advantages of use Rebase instead of merge. Another one is that when you use Rebase, sometimes it's much more easy to have a clean pull request that people can review on GitHub. Jessica, people have questions there?
Can you repeat the first part you said right after you did the git commit local merge? Because I think your audio went out there. Okay. Yeah, that's okay. So you dropped out. Yeah. So can you go over the first point that you made again right after you did the git commit local merge?
Okay. So
thanks.
The first advantage of using Rebase is that you only have a merge with very commits that's on times very short from the parents and the merge commit. So this will make your gate tree very easy to read instead of having too much parallel branches that come from a very old time and then merge in the future. So in this screen, you can see this commit right here that from A1C25 that starts, that whose parents is EC0F7, and it was merged on F4AB, so it's easy to track this one. But instead, this commit D0F4 that you use a merge, it's much harder to track because their parent is this one, 3F3C1. You can see the green line here, and was merged on B52F6. So this is the first advantage of using Rebase. The second one is that when you're using GitHub, Rebase will ensure you that you have more clean pull requests for people review and make comments. So this is the two advantages of using Rebase. A few projects have some preference to use Rebase or not, and a few programmers has their personal opinion of Rebase and merge. But I personally I prefer using Rebase just to keep a clean Git tree on that. So any questions on Davis, Jessica?
We're seeing if you have questions. So the question was, is it correct that rebasing changes the branch and merging changes the head?
What is the? Can you just repeat what the exact difference between rebasing and merging?
Okay. So what's the difference between rebasing and merging again?
Okay, so when you merge, you keep the comments that you have on your Git tree. So no comment is lost. When you rebase, you change the comments ID of the comments that you are rebasing. You change the parents of that commit and other steps. Like if you cut a branch of your tree and another one start in a different point that has similar changes, but it's a different comments for Git and everything. So The reason that some people avoid using rebase is just to preserve the comments, because that's why you probably going to use version control to keep track of your history. But in some cases, as I mentioned, using Rebase will ensure you to have a clean gate tree. So if you prefer to get a tree that's more clean and readable, you're going to recreate the comments that you have instead of just merge them in a different point. This answers the question?
Yep, that's exactly what we're looking for.
Okay, so let's go to a challenge. Let's rebase the two branches that you still have on our list of pull requests. So we have the can't branch and the voluntary branch. Let's rebase those, send to GitHub, and match using GitHub interface. I'm going to add that on the Etherpad. So challenge 6. So rebase the branches can't and voluntary into master, then push them to GitHub and merge the pull requests using GitHub web interface, and then update your local copy with the changes from GitHub.
Okay, we will get to work and I'll let you know when we are done. Okay, I think we're ready to go over this.
Okay, so let's go. So let's get out and can't get rebase master, and let's solve that conflict. If can't. Let's go to the end of the file and preserve the four things. Get status, get add, and the file get status. So it's okay. We are okay. So we have here rebase in progress. If you want to stop a rebase because something you are not sure if everything it's okay or for any other reason, you can use get rebase abort. So this is very interesting when you want to stop rebase. So get status and you just go back to campus with nothing to do. It's a very useful option. So let's go back again. And with that rebase, get rebase master and solve the conflict. Get add the file, get rebase continue, and get push F orange and you can go to GitHub and merge that pull request now. Okay, so that's green, and let's merge. Again, we need to fetch the data, get fetch orange, get out master, get merge orange master, get, and now that you have the local copy of what the merge that you just did on GitHub, you can go to voluntary and merge that git checkout, get rebase master. So that's no conflict on that. Okay, we're done. I forgot that. We just already merged all the branches. So what happens here on the last one? That it creates it's just something that is important. If you rebase a branch that was already merged, it's just going to change the position of the thumb tag. So what's what happens? We just rebase the voluntary one to master, and since the voluntary was already merged into master, we just change the thumb tag from position. Questions from Davis? Jessica?
I don't think we have any questions.
We have more 10 minutes, I think. Is that?
Yeah, we have some more time, but I don't think we have anything. Let me take a few minutes and let me see. Maybe if anyone has any questions, they can put in the Etherpad, but if not, I think that might be it.
Okay.
Okay, I think we're all set. thank you so much for teaching this. And yep, the video will stay up. So that's
Okay.
thanks.
Thank you,
Okay.
Jessica. And thank you to everyone on Davis and everyone that is watching this tutorial. Thank you very much and have a good day.
Thanks, you too.
Thank you.
Bye-bye.
Bye.